Assalamualaikum and hello. Welcome to chapter 7 where we are going to learn about chemical bonding. In this first subtopic, I'm going to focus about valence electron and Lewis structure. So first, in this video, we are going to learn about the first subtopic, basically for valence electrons and Lewis structure. These are the contents of the first subtopic, and the second one you are going to learn the second subtopic, molecular shape, and you are going to learn about the last subtopic, 7.3, intermolecular forces. So I'm going to divide the notes into three where you are going to learn based on their subtopics. So let's get on with the first one. At the end of this video, I'm going to focus about the first learning outcome where we are going to learn about how to write the Lewis symbols for an atom. As you see here, we got quite a lot of symbols that you see around us, where we know that these symbols are used to give information and contents in the easiest and simplest way for us. However, in chemistry, what does this symbol mean? As you see here, we got the letter O with some dots around it. So what does it mean? So that's where I'm going to introduce to you about chemical bonding. So chemical bonding only happen when atoms interact to form a chemical bond, only with their outer regions in contact. So which means that we are going to focus about valence electrons for that atoms. So in this chapter, you are going to use your information and your learning during the previous one where you know about valence electronic configuration. And I hope all of you should be memorized some of the elements in specific periodic table based on their groups. For example, you know halogen is in group 17 and then noble gas group 18. So you know how many valence electrons they are. So let's focus to valence electrons. We know that they are the outermost shell electrons, which is the electrons that are more further from the nucleus. And they participate in chemical bonding. So I separate some of them into a few terms where in group, their electronic configuration and how many number of electrons they have. For example, we have group 1, so the electronic configuration NS1, and N is referring to the principal quantum number, or the other way is your shell, and then the number of valence electrons is 1. And then the second one, we have group 2, group 13, until group 17. And you see here, this N value, I didn't put any value here because you have to expect based on the questions. And if we talk about the valence electrons, so it means that this is going to be the highest N value you have for that element, due to it as a valence shell. So let's go to the Lewis dot symbol. So Lewis dot symbol is a symbol where we are going to use either you use a dot like this or crosses like this around an atomic symbol for that element to represent as the number of valence electrons. And actually, Lewis symbol is based on your electronic configuration for that element. So that's why you have to know how to write the electronic configuration. And then elements in the same group usually have similar outer electron configuration, and of course similar number of valence electron, and also of course the similar number of dots. We take it as example 1 where I have the electronic configuration for oxygen is 1s2, 2s2, 2p4, and you see here that the largest n value or the highest n value is n equals to 2. So that's why the valence orbital are in the subshell 2s and 2p orbitals. And you know that in 2s and 2p orbitals, the total number of electrons as your valence electrons is 6. So 6 dots around the oxygen. So how you write it down, you will put the atomic symbol for oxygen, which is capital O, and there will be 6 dots around the element symbol. So that's how you write the Lewis dot symbol for the element. And for example, we take it from the previous slide where we have the number of different elements based on their groups, and then how I want to write the Lewis dot symbol for that element. For example, we take it that element as X. So I have X with 1 valence electrons, so it means that 1 dot symbol. And then for X in group 2, so it will be 2 dot symbol. And then X in group 3, it means 3 dot symbol. And then for example, I want to put the unknown X with 4 valence electrons. It's going to be 1, 2, 3, 4. Penuhkan setiap side dahulu, barulah awak make it as a couple. And then 5 of them, it will be 1, 2, 3, 4, and then 5. Put the last one whichever side you want. And then 6 of them, 1, 2, 3, 4, 5, 6. Okay, I make it as symmetry like this. And last one we have 7, 1, 2, 3, 4, 5, 6, 7. So this is how you want to draw or write the Lewis dot symbol for the elements given. And make sure in your question be specific. What is the symbol for the element X? It is. Next one, I have example 2 where I want you to state the number of valence electrons and Lewis symbol for aluminium and nitrogen, and we have the proton number. So let's go to the solution for question A. I have aluminium with its electronic configuration as this one, 1s2, 2s2, 2p6. And then we have 3s2, 3p1. And you see here, the highest n value is n equals to 3. So it means that in n equals to 3, we have 3 valence electrons. And the Lewis dot symbol is going to be the first, the symbol for aluminium, Al. And then how many dot you will have around it, it will depend on the number of valence electrons. So it's going to be 3 dots. So I put 1, 2, and 3. So just like that. And then we take it for the next example, we have nitrogen. So nitrogen, the electronic configuration with 7 electrons, you will have 1s2, 2s2, 2p3, and each of them in each room of 2p orbitals. And what we'll see here, the highest n value is going to be n equals to 2. And then if you want to determine the number of valence electrons, it's going to be 5. And the Lewis symbol is the symbol for nitrogen, and you will have 5 dot symbol around it. So put each of them at each side, and after that last one you put at any side you want. So this is how you write the Lewis dot symbol based on specific elements that I give to you. So I hope you clear with Lewis dot symbol, and sometimes you can also use cross symbol. For example, I have nitrogen, I want to use cross symbol, so I put a symbol for nitrogen, and then after that I use cross 1, 2, 3, 4, and then 5. So this is also acceptable. Okay, so either you use the dot symbol ataupun cross symbol, dua-dua diterima dengan syarat examiner boleh bilang bilangan dot dan cross symbol itu sama seperti mana bilangan valence electrons for that elements. So that's all for this video. For the next video, we are going to focus about octet rule. I'll see you in the next video. Thanks for watching. Bye!